Okay, chapter 2 is not only the polynomial chapter, but most of it is. Then we end with what's called rational functions, which is fractions with the asymptotes and all that. But mostly it's polynomials. So we're going to start small with the small original polynomials, which are the linear functions, and then quadratic. What's a quadratic end up graphing and looking like? Parabola. Okay, but then I did put in here, there is one more name, and then after that there is no more names for the degree. An x to the third will be a cubic, and then we start getting into the polynomial dance, which I don't know if anyone did that at twerp. Anyone? It was at twerp. Didn't go, but if you went, polynomial dance, arms in the air, like you don't care. We're going to get into that. X to the thirds, fourths, fifths, and doing a whole bunch of mathematical operations on those. And you may or may not have done those. I don't know what you did in Math 3. A little disconnection with the Math 3 program. And actually, whatever was done last year is being changed this year again. So, whatever. Um, okay, so the first stupid little game that they make you play, concept number one, you can write this or not. It doesn't matter. Just look at it. All they ask you is polynomial, not a polynomial. It's just like function, not a function that you played at lunch with your friends. Didn't you? Okay, well, that's okay. You don't have to. All right. It's fine. Neither do I. You know, my friend in high school was my math book. We went to prom together. Anyway, um, so polynomial functions. Is this a polynomial or not? Well, the only thing I could say, and I don't care that these notes are clean and they're old, it doesn't matter. Look up here. Do you see the circle? Do you see it? Is it circling? Is it frozen or not frozen? Not frozen. Things that are polynomials are just a variable with a whole number power on it. Whole number does include 0. X to the 0 is 1. Y equals 1 is a polynomial of degree 0, believe it or not. All right, x to the first, second, third, so on and so forth. So what I put over here is a couple of examples of not polynomials. Square root of x, because it's x to the 1/2 power. When you rewrite that, you better know that. We talked about that. X to the negative first is actually equal to 1 over x, which is actually called a rational function when you have a variable in the denominator. So really a polynomial is I don't care about this half, that's just the term at the end, the constant, for x to the third, 5x to the first, even though it's a ghost there. A is a polynomial. B is not, because this actually equals this when you rewrite it. Not the 6, not the 6. 6 stays up. Maybe some refreshers of math things if you want to write that down. But this is called a rational function. It actually graphs different than what a polynomial does. No, C does not work like this blue. That's like saying the square root of 16 plus 9 equals 7. But what is 16 plus 9? Because that's the order of operations. What's 16 plus 9? 25. Too late. What's the square root of 25? 5. Huh? Because what people do sometimes with this is do the square root of 16, the square root of 9, and then add those two. That's wrong. Improper operation. So C is just completely not a polynomial. Oh, you're killing me, Smalls. Okay, then D is a polynomial. And then here's, when we play the polynomial game. I'm sorry, the polynomial dance. What can we expect? You can't see this on the video. I should tape myself. I can't actually tape my face. Yeah. Shh. All right. He's very talkative today. All right. A, B, C, or D? What's correct for 4x to the third? A, B, C, or D? Oh man, I'm getting a whole bunch of letters. And it's actually A. A was this one. For your perspective, this would look like this. That's why we want to know the degree and the leading coefficient, because then it tells us what the graph will behave like on the ends when we plug in infinity and negative infinity. Then D, we want to know the leading coefficient and degree 4, because it's either A, all right, fine, B, I can't do this one, there we go, C, or D? Which one is it? It's D as in Danny, which is my name. Don't ever call me that. Okay? You got to know that an x to the fourth ends the same way as it starts, and it ends down because of the leading coefficient. So that's why you'd want to identify those things. Whatever. Then the next one, I'm not even, I think this is old student writing here. No, this is all my writing. The only reason you want to write this one down is it's a little tricky in its format. Remember, most of this chapter is about polynomials. One type of polynomial is a linear function, an x to the first. But notice how this is worded. Write an equation of a linear function such that, what is this? All right, and we should already know this, so that's why I'm just shoving the notes in your face. Plus on a day where half the class is taking a test. You should know that this just means input, output. So it's just a sneaky way, it's not really sneaky, it's a mathematical way of writing x comma y and x comma y. It's just in function notation. So all I have to do is extract the x comma y's out of this notation, and 2 points make a line. Find the slope, and then actually what I always do is I always use what's called, well, that's the blank, and this is one of the blanks of the line. Point, slope. This is point slope form. We already tested you on this in chapter A and P, the prereqs. Then this is called slope intercept form, which all that's required for this is to rearrange stuff. Distribute the -1 and then add 2. I shouldn't have to teach that, not at this level. Oh, but then we did for the first time talk about this form, which this form is found just by adding x and subtracting 1. Does anyone remember what this form's called? They're higher up in the Army, Navy, Air Force, Marines. General form. Nicely done. Remember that? Just a little reminder of what we've already done. Well, you should. The next line of polynomial is a quadratic. Next stage, x squared. Okay, so this looks like a bunch of rigmarole, but it's not. There's actually 2 forms of a quadratic that we want to know. This is called standard form. And then this is called vertex form because the vertex is staring you in the face. The vertex is opposite of minus h is h, comma, same as k, k, h comma k. Remember that? Opposite same? Inside parentheses opposite, outside same. This tells you how far right and left you go, how far up and down you go. And what that does is makes a new vertex compared to just x squared, which would have a vertex at 0, 0. Okay? Now, we're going to teach you 2 things. Off to the side, oh man, 2 years ago, we did parabolas till, just so long. And I just don't know what else to say about it. And we did this little thing about how to find a vertex when you're in standard form. Do you remember that? Okay. Well, you're going to have to, because I'm going to make you do that, but I'm also going to make you do a process that's called completing the square. We're going to do both, and you're going to like it. All right? And then we'll see the relationships. In the first 2 examples, I'm going to do both. I'm going to take a parabola in standard form, find the vertex, and then from that vertex, I'm going to convert it to vertex form. But then what I'm going to do is come back and take the same one and complete the square on it and introduce you how to complete the square. Because the process of completing the square is a necessary mathematical, I don't want to say operation, a skill. That's the word. And it's really going to be huge in Chapter 8. So this will be the first time you do it, and I will expect to see the mathematical operation of you completing the square correctly with work shown. So you're going to be responsible in this chapter to do that. Blah. But you also be responsible to remember this. Do you guys remember this? Okay, so by the way, as you're writing this down, I see a lot of people writing. This is the x-coordinate of the vertex. B is the middle term. A is the first term coefficient. So negative b over 2a just magically gives you, there's a reason behind that. You can equate it to the quadratic formula. Doesn't a quadratic formula start with the opposite of b, right? Plus or minus blah, blah, all over 2a. All right, so it is derived from where the x-intercepts are. The x-coordinate of the vertex is exactly in between those two x-intercepts. Whatever. What does this mean? What does that mean? It does mean the y value, but what does it mean? How do I find it? Are you putting your hand up? Go ahead. Yeah, whatever you got for x, you plug it into the function and evaluate y. That's all that means. Okay, so that's what we'll do first on this Mickey Mouse example, the one to the right. So don't look. I don't care that my notes are ugly. It doesn't matter. I used to write all my notes on the board, on the whiteboard. Oh, I used to love those days. Now we got all these computers and everything's online, making movies, and you kids these days. Okay, now, what's the vertex when we're in this form? The vertex is found by first doing negative b over 2a. Remember these notes back in the day in regular algebra 2? Boy, do I miss that class. So, what goes up on the top? Negative, everyone? 4 over 2 what? 1. Negative 4 divided by 2 is negative 2. Do you remember doing this? Some people are almost falling asleep. I'm trying to teach quietly and calmly without yelling at the students because half of them are taking a test. That's the x-coordinate of the vertex. Yes. All right, next. You plug that in to find the y-coordinate of the vertex because that's how you find any y that corresponds to an x. All right, then what do we end up getting? Let's just evaluate that. 4, negative 8, negative 9, right? Now, what number is in front of this x squared? This is important to kind of 1. So when we convert this into vertex form, the a values are the same. So it is 1. But then what I can do now is write this in vertex form. What's the x-coordinates vertex? So what does that mean goes in here? X plus 2. Don't ask any questions on that. And then what goes out here? Minus 9. Look at how the formula works. That's it. Or you could do this hard process. Now, again, I'm going to hold you responsible for remembering this because of your Math 2 days. We did that a lot. We actually had that negative 16t squared formula for an object thrown up in the air. I think we spent a week on that formula with you guys, analyzing the picture of what it looked like and all this other stuff. Get your old notes out from 2 years ago. You'll see a whole bunch of examples on that. And finding the vertex of those examples actually found the maximum of the flight of the object and at what time it hits that maximum. Anyone recall that? Okay, some people. All right, but anyway, now let's do this a different way. Let's see how much room I have. Oh, I have so much room. All right. So let's take this. So that's one way to get the vertex form. Another way is a way you're going to be responsible for. So what was it? X squared plus 4x? What? Minus 5? Okay, now. This is brand new. Maybe it isn't. It depends on your teacher. Here are the steps. I'm not writing them in words. What you want, though, look, you want to be able to have something that's something squared. So you want to be able to factor something that's a perfect square trinomial. And I'll tell you what that means in a minute. So step 1 is we group these two x squared and x terms, no matter what they are. Now wait till the second example. The second example has a complication in it. The reason I can't group these right away is this is a 1x squared, so we're good. Anyone ever complete the square before? Okay, I knew that. I bet you I thought so from your other school. All right, now, just answer me this question. We know f of x is the same thing as y. If it helps you just make it y, that's fine. But whatever I do to one side, say it. So guess what? I'm going to do something to both sides. I'm going to add something to both sides. And where I'm going to add it is right here. I want to make this a perfect square trinomial so that when it factors, it's a binomial times a binomial, which is a binomial square. Close. This is how you do it. Now, I'll tell you when to repeat this. And we're going to say it like 7 times today till you're annoyed. When I say complete the square, don't say anything yet. Here's your part. When I say complete the square, you say take half the middle term, square it. You're on. When I say complete the square, you say what's the middle term? 4. Just 4. What's half of 4? 2. I'm going to write it real small here. What's 2 squared? Put it there. What you just created is a perfect square trinomial. You've created something that factors to be a binomial times itself. But whatever I do to one side must do to the other. So what do I put here? This is the step that people always miss. They just get so focused on completing the square they violate the rules of equation balancing. All right, now let's analyze this. I can only help you if you're a good factor. You've made a situation. Again, notice we're ignoring that -5 as if it doesn't even exist. Okay, what multiplies to 4 and adds to 4? Those two same numbers, and what are they? 2 times 2, look, 2 plus 2. So look at what this factors to become. X plus 2, fine, I'll write it, times x plus 2. But what should we write that as? See, look, x times x, is that good formulas are good factors, right? So the final thing is to subtract 4. And then what you have is y equals, or we could call it f of x, what we had to begin with in that other method of doing it. Now, I'm not going to write that as a binomial times itself anymore. We got to be good factors. Okay, what's different about this one? I mean, let's look at it. What's different about this one? The -3. It's a huge issue, and I have it underlined. And by the way, if they're mean and they give you a, oh, let's mess with the students, let's put it out of order. Put it in descending order before you complete the square. But here's the thing. What did I say? When I say complete the square, you say, so take half of 6. What's half of 6? What's 3 squared? If you just do that and do this, all I can tell you is this. This is not even factorable. That's not even factorable. So you did not make a perfect square trinomial that factors to be nice little binomial times binomial. So just understand that. There is a big issue with there being a -3, and it does create 2 problems. So this is the one I'm going to do complete the square first, then I'm going to do the -b over 2a thing, if you can follow with me. You do this, yes you do, but what do you do next? Wow, your voice has changed. And you could throw it you should make a career out of that. Okay, so y, now watch this. You could still do all these steps at once, kind of. Not -3x. You didn't say that. But last hour when I picked on a student, they said, take out the whole GCF. No. What we want to make happen is this is something that I can factor with a binomial times itself. The -3 doesn't allow that to happen. So we pull it out. I was stopping. What's the 6, do you think, become? -2x, and then you put the blank in here. -5 has nothing to do with this game. You treat it just like, you're nothing. Get away. Just go out there. You're by yourself. Like Mr. Samus on the playground in grade school. Aww. Anyway, I know. I like throwing those little things in there. Did I say the book thing on the video too? Oh, jeez. Wow. He needs help. All right. So now, look at this. Now I can complete the square on that. When I say complete the square, you say half the middle term and then square it. What's half of -2? By the way, -1. I'm just going to write this. I didn't write this last time. Then what? And then what goes here? Okay, now we're all going to get this wrong. What goes here? You got it wrong. Negative. Oh, not -1. Not 1. Whatever you do to one side, you do to the other. What'd you actually do to the right side? -3. You didn't add 1 to the right side. You added negative 3 times 1 to the right side. Oh. So there's two problems when there's a number in front of the x squared. You got to factor it out, and then you also have to understand what did I actually add to the right side. That's what I need. This is the balance. You got to keep this equation balanced. Okay? Now we can go ahead and finish this off. And I think fumble. You can almost do all this here. Okay, how do I get rid of this minus 3? I add 3 to both sides, and then you can factor and you'll have your final answer. So we could get this done in 2 simple steps if you just keep everything in order. Because now, how does this factor? What multiplies the 1 and adds to negative 2? What two numbers? X minus 1 times x minus 1. Look, remember this because it's going to get crazy. All right, and then minus 2. All right, so that was the second way I showed you in the last set of notes by completing the square, which you're going to be responsible. Let's just play that first game, though, and just see that it does coincide. Let's take this original and do negative b over 2a. What's b? What's b here? 6. What's a? What's negative 6 over negative 6? 1. Huh? See it? X minus 1. And then when you plug in, and oh, I like this way better. Why should I even have to complete the square? Because it is a process that you're going to need later. It's true. Okay, and then I'm not going to bore you with the details. You do get negative 2 here. But here's the problem with this. If I didn't have you do this, okay, I get the vertex to be 1 comma negative 2. How do you change this to vertex form? The a's are the same. So it would be y equals, you have to take that negative 3 and put it there now, and then put it in vertex form after that. So understand, try to separate this into 2 different questions, like, how you convert it to vertex form using the negative b over 2a way. Now I'm done with the negative b over 2a way. That's review. This completing the square may or may not be. Even if it is not or is review, we'll go through this one. This is still an easy one. The last one is going to rock your world. All right? What do I do first, everybody? Okay, this is what I would do. I instantly would do this. I get it all done, right? I want to get this done in 2 steps. What do we do here, though? What do we do here? Take out a 3. What's left over? Plus blank. And then remember, you treat 11 like it's nothing. Just get it out there. It's not part of this whole process. When I say complete the square, you say take half the middle term. What's half of 4? 2 squared is what? Notice how I'm writing this here. There's a couple reasons why. It's really for the next example. All right? But what goes here? 12. You got it. Okay, so don't make that mistake ever again. And then you can subtract 12 and you can actually write your answer. It's y equals 3x what? Plus 2 squared minus 1. And then one thing I didn't do in the last ones that I did with the other classes, you could graph this real fast then. Vertex is where? Where's the vertex? Negative 2, negative 1. Right? And then we can prove this. And it really does make me angry how many students don't get how to graph just by plugging in points. It's infuriating. That's why I said, ooh, people are taking a test right now. You run out of time on your tests because you rely on your graphing calculator to graph every every stinking thing that you see on the screen. You're a robot. You're controlled by a machine just like your cell phone. Is it called a cell phone anymore? Smartphone. Excuse me. All right. All right, now, which way should this parabola go, by the way? Up. Now watch this. I plug in negative 1. What's negative 1 plus 2? 1 squared. 1 times 3 is? 3 minus 1 is? 1 comma 2. What should I get when I plug in negative 3? 2. What's negative 3 plus 2? Negative 1 squared is? 1 times 3 is? 3 minus 1 is 2. And then some things they may ask you about, like here's some things for a parabola. What's this called? That's a line of symmetry. What is that? Axis or line of symmetry. X equals -2 is called the axis of symmetry. Something I kind of threw at the end there for the students last hour. We'll just get it in there now because I don't want to overdo the notes too much. Right, and then the ability to graph it, knowing the vertex and knowing how to plug in a couple simple points. Shouldn't be rocket science. Now here's the world rocker. Dun dun dun. Someone tell him why this is gonna blow somebody's brain gaskets. Well, you can. What happens to the middle term? It's a fraction, and you better darn well, boy did I want to swear there, put a decimal. You better accept your fractions like they're your friends. I just spit all over my screen with all those F words. So yes, you take out a 2, you ignore 7, and what does 3 become? -3, of course, but what does -3 become? 3 over 2. And leave it. Do not make that 1.5 or 1.5. Because I'm telling you, you're circumventing your own failures. Circumventing? I don't know if that's the right word for that. That's fine. It says in English. When I say complete the square, watch how easy this is, by the way. When I say you touch that calculator, if this was Providence, I would have taken that ruler and smacked that finger, and I got away with it. Anyway, when I say complete the square, you say take half the middle term. Wait a minute. How do I take half the middle term? This is so easy. This becomes what? -3 over 4. And then what do I do to it? Then you're going to get real mad after this part. But this isn't hard. I could teach my first grade daughter to square that. She knows how to square, I think. Okay. Hey, honey. She has no negatives. All right, fine. All right, but what's 3 squared, honey? She would say 9. Honey, what's 4 squared? 16. I'm talking to my daughter, not a student in class. It would be wrong. Okay? And you put 9/16 there. All right, now you might get mad. You expect me to factor this? I've never factored anything with fractions. The answer's staring you in the face. What multiplies to 9/16 and those same two numbers add to be -3/2. I know that's going to be a stretch. What's -3/4 plus -3/4? See, again, this is just simple fraction work. This is why I want to throw my computer. How many students don't know they're simple fractions? What's -6/4 become? So this number adds to this one and multiplies to be that one. So do we know how to factor this? Yes, we do. So I'm getting rid of that. Delete. So on the right side, we have this. Now I'm taking this slow because there's another problem. So it's x minus 3/4 times x minus 3/4. I'm going to write it like this time. Whoa, that was a brain misfire. Because x times x is x squared, -3/4 x and another -3/4 x. I just proved this -3/2 by the adding to make it -6/4. And then -3/4 times -3/4 is 9/16. So this is how this factors. Here's the other problem though. What goes in here? And the answer is not 9/16. It's 18/16. Or in reduced form, it's 9/8, right? Because what you added was 2 times this. So when I put a 2 up here, the 2 cross cancels with the 16. That's how I simply get 9/8. So there's two problems. Being able to factor with fractions, and then being able to figure out what is this number actually to keep the balance. And then after that, we could subtract 9/8 from both sides, and then I'll write the final answer below this. By the way, how do I take 7 minus 9/8? What do I have to do to 7? 7 over 1 becomes, no time, 56/8. So the final answer is y equals 2 times the quantity x minus 3/4 squared. 56 minus 9 is 47 eighths. Not a glamorous and pretty vertex, but it is what it is. And then to graph that would be kind of a pain to see the symmetry, because 3/4 for an x value, it's hard to see the symmetrical points when it's not a whole number for the x value, but at least you're able to find it. Now we're gonna get medieval on you here. Ready? Yes. We're gonna do another one. And I don't care. You could shut off the video. You could shut off the video at hello, so it doesn't matter if you're watching this or not. Okay, somebody pick a number that's not 1 between 0 and 9. 7. I heard 7 first. 7x squared. Now this is what I want. I want an even number between 0 and 9. 4. I don't know. What'd you say? Okay, you did say 4 too. That's interesting. And then just pick any number between 0 and 100, positive or negative. I like 99. And let's make it negative. Because your ability to do fractions is not hindered by this. I mean, you should be fine. Please stop doing that. Okay, now, what's your first step? Take out a what? What does minus 4x become? What's minus 4x become? Minus 4, I mean. Minus 4 over 7. Now, this is why I've been doing this, and I didn't do it with the other hour, but it's not that I messed them up, but we're going to do our work here where I say, okay, and the whole point is, remember, you can't complete the square on 4 minus 4x because the 7 screws it up and you don't get a binomial squared. All right, we went through that. So when I say complete the square, you say take half the middle term, stop before you do the next part. How do you take half of this? What cross cancels? So this becomes what? Negative 2 over 7. So I've taken half of the middle term. Remember how important this number is, by the way. And then what? Square it. Again, I could get my first grader to square 2. What's 2 squared? Why didn't you do the negative? Because the negative squared is a positive. What's 7 squared? I think she does know 7 squared. She knows 7 times 7. Yeah. Okay, let's get this over with. What goes over on this side then? It's actually not too bad. 4 over 7. It baffles me the amount of students that can't put a 7 here over 1 and cross cancel. 7 goes into 49. All right? That is not a major calculus concept. Then actually, we're almost ready, but I'm going to take it slow. What is this in factored form then? What multiplies the 4/49ths and adds to be negative 4/7. This one actually flat out does work. So what's this factor to become? X minus 2/7 times x minus 2/7. Then the only thing I didn't handle was subtracting 4/7 from both sides. What? That was a brain gasket. Someone on their calculator take 99 times 7. Real fast. I want to write this over 7. 99 times 7. Huh? 693? I hope she's right. She just put that in her brain. Does nobody have a calculator in this class? Is that right? All right, and then you add that, and then just maybe see that if it reduces. So we just randomly grabbed 3 numbers out of the air, and they were ugly and don't mesh with each other. But I'm telling you, the ability to complete the square on it is just as easy. It has to, I mean, it's only as hard as doing fractions. Okay? That's it.